Hi, so for this problem, we get that the present value of these for liabilities and decides to create an investment portfolio by making investments into two of the following three zero coupon bonds in the company like its position to be Reddington, immunized, and then they can do this. Okay, again, what are the rules for Reddington immunization? That the present value of assets equals those of the liabilities, that the duration assets are also equal to duration of liabilities. Another thing is that the convexity of assets are greater than the convexity of liabilities. Now we're able to solve. So we noticed here that if the present value given is 9697, then that would mean that the portfolio of all of these bonds, this is present values, must also equal 9697. So we should denote these, first let's denote these bonds as X, Y, and Z, which means that also since they are zero coupon bonds, the prices that are associated with these bonds don't need any discounting. We usually just add up their face values to determine if their present values equal 9,697. So we're gonna first do this case of X plus Y plus Z equals present value of 9697. The second case involves duration, so that would mean that again we only multiply the duration consists of the time value each zero coupon value has. So the equation for that would be 5x plus 15y, and there's no discounting either because they're zero coupon, so it's just the time value plus times the price, 20-year Z over the present value of X plus Y plus Z equals to 15.24. Now, next thing here is that the Macaulay convexity. So what does that mean? So the Macaulay convexity would be set up in terms of the time value being squared. So it would be 5 squared times x plus 15 squared over the present value, which is equal to 242.47. Now, the first thing that we could do is we want to solve for these variables so we could get values for it, right? But there are three variables that we don't know of. So what we can do is we could set one of them to equal to 0 to solve for the other two. The thing is that out of all of these zero coupon bonds, the only coupon bond that is greater than the duration given is Z, right? And the rule states that durations have to be equal to each other. So Z cannot be equal to 0. It's only either X and Y that could be equal to 0. and that means that we would have to solve these equations based on either both of these, right? And we also have to test both of these out. So let's first test out setting y equals to 0 so we can find what x and z is equal to. So what we're going to do is, well, we're just going to depend on simpler equations by using this equation, the present value equation, and the duration equation. So what I'm going to do is I'm just going to set y equals 0, and I'm just going to make x plus z equal the present value of 9697. And I'm going to make x equal to 9697 minus z. Now I'm going to substitute x in this equation right here. We already know what x plus y plus z is. It's given here. So it's 9,697. So to simplify, I'm going to simplify. Now I'm going to do 9697 times 15.24. So it's going to be 147,782.28, right? So since x is equal to 9697 minus z, I'm going to take this right, plus 15y, y says 0, so okay, and then 20z equal to right, and then we're gonna distribute this. Right, and then we move this to the other side. Which is that, keep changing, 15z. Divided by 15. So z is going to be equal to 6619.81, whereas x is going to equal, since we set y equals 0 here, we're going to just subtract it from 9697. Going to get 6619.81. We're going to get 3077.19 as x. So we found our two values. Now what we're going to do here is we're going to make a convexity equation, because we've already dealt with both these. So we want to see if convexity agrees, if their convexity of assets are greater than the convexity of these liabilities here. So we know the convexity of liability is this. So now let's formally solve for this. So bond Z, denoted as the 20-year. So let's multiply this by 20 squared, because that's what convexity entails, plus 3077.19 times 5 squared over the present value given, because we set it equal to each other. So now let's solve for the convexity and see if it's greater than the one we have here. So it's going to be 272453 divided by 9697. So the answer I'm going to get is 280.99, which is practically 281. So we see here that this convexity is clearly greater than this one, which means that if I were to, so it all works out fine by setting y equals 0. So if I were to look at the answer choices, I would see that I am able to invest 620 for the 20-year bond and 3077 for the 5-year bond. And yeah, it worked. That's why A is the right answer. If I were to set y equals 0, no, if I were to set x equals 0, what would actually happen? Well, I maybe would have just set y equal to this, and then what else would I have done? I would also substitute y into here, right? 15 y plus 20z, so then this would become 145455 minus 15z. So then I would move this to the other side. Right, 2327.28 divided by 5z, which is 465.456. So that would mean that z would be equal to 465.456, whereas y would equal to 9,231.544. Now, if I were to look at the answer choices here, 465 would be 1 here. 9231 would also be here, so E could have been a possibility. But I think if I were to solve it using the convexity strategy, so if I were to cross this out and replace it with this value, and then if I were to cross this out and replace it with 9231.54, and then this is 15 years, right? So let's see if that would be greater than the convexity here. I would do 465.456 times 400, right? And then plus 9231.54 times 225, okay, divided by 9697. It would give me a convexity of 233.9. 0.39, which is less than the Macaulay convexity here. So that is why the option of making y equal to, no, the option of making x equal to 0 would not work out in this case. Even though if we did start with x equals 0, we would have to test it out. But we just also have to remember that we can't set the variable that is much greater, especially if it's the only one that's much greater than the duration at 0. So that's why z was never made to be equal to 0. And that is why e doesn't work out as well.